Hello, welcome back. Hope everybody doing well. Open a new page. Part. Okay, today I'm gonna to talk about. Firstly, in this part I'm gonna to introduce a new tool which is called as Reeb. Okay. Now select right plane, normal to. Use line. Start from, as always, origin point and make this sketch. Dimension. This one is 10. Here is 30. And this one is this one is 40. And this one is 10. Okay, isometric, extrude, and confirm. Now we have this part. Select this plane, features and plane. We have to wait for some second. Okay, change direction here, flip direction, and put 30. We need a plane at the mid of this part. Okay, now already this plane is selected, normal to line. I'm gonna, as I said, introduce a new technique which is called as Reeb. Reeb, all the sketches which already needs a closed sketch, but this one is all the time is open. It means that if you create a line, you can make a Reeb. For example, make a line from this point to this point. Okay, definitely this line do not need any dimension. Have a look in isometric view. We have only this line. We don't have any line here. Okay. Now go to feature and use Reeb. Okay, now in Reeb you have to look here. This is the direction of the extrusion which will be down. This direction is very important. You can change. Here we have three tools. You can change the direction of this Reeb. Look, this one is in this direction, but it is not correct. This one is in this direction, and the flip of material might be down at this direction or this direction. Definitely, since we are gonna to build a Reeb here, you should click on this. You should select flipped material side here. Okay, if you do not do it, definitely this one will be not correct. Okay, so. And if you wanted to, this one is in both sides, and if you wanted to have only on this side, you can use these icons as well. Okay, so you just need to be careful. You should select both sides, and the direction of the flip or extrusion should be selected as mines. So you will do it, and you will be able to create this Reeb. Okay, very quickly we can make a Reeb, but as I said, since we are not gonna to use this plane again, I'm gonna to hide it, and I have a Reeb here. Okay, so let's go let's start another part to work another part here. Open a new part. Okay. In this part, I'm gonna to show you we can create conical parts using the extrusion. Let's start in top plane, normal to, sketch and rectangle. This one is rectangle. Make a rectangle here. The direction which I'm looking for is 68 and 68. Okay, and now let's extrude it by 15 Okay. Now, as I said, I'm gonna to show you how we can make a conical part here using the extrusion. Now, select this plane, normal to, make a sketch here, rectangle, from corner to corner. Okay. We have a rectangle, just merge with the previous rectangle, isometric. Now, feature, extrusion. Extrude, we are gonna make a conical part here. The angle which I'm looking for is 20. So I have to select on here, draft on, okay, and here the degree you should select 20. Okay, 20 degree. Height which I should build is 27, sorry. Okay, now I made this part. Okay, now this one, select here this plane and use line to build this sketch. Okay, now be careful, we have a line here. Okay, this is a closed, it should be closed. Okay, dimension between this point and this point, this height is 6. Okay, and this point to here is 12. Here, point to line, oops, points, this point to this line is 1/8, and this one to here 18 and 12. Okay, I made this sketch, it's quite black, it means that it is fully defined, and now it's time to use cut extrude tool. Okay, now I'm gonna to make another grow here, but selecting this plane is not correct, because if you select this plane is not a vertical plane. Much better to work on this plane. Normal to, it's a vertical plane, ISO, sketch, rectangle, make a rectangle here. The dimensions which is given on my paper is definitely I will try to show this paper is in a course portal. In the course portal I will share this for this files with you. This one is 15, here is 15 again, and this one is 15. Okay, so the distance here given as 15s, all the distances 15s. Now isometric, and let's say feature, cut extrude, and here you should select true. Yes, this here is another part which we try to make. Open a new page, part, okay. I'm gonna to work on top, normal to, sketch, and rectangle, build a rectangle here. This one is 42 and here is 98. Okay, isometric, feature, extruded by 22. Now, come here, select here, normal to, isometric, make a rectangle here. This one is 5, 70, and 14 here. ISO, feature, cut extrude, and let's try true. Now I'm gonna to select this plane, normal to plane, select this plane and make a plane, change direction, and this one is 49. It's on the mid of this part. Okay, confirm, normal to. Now use a sketch and make a line from this corner to here, another line here. If you have, as me, if you have problem with this plane, you can get this plane and put another point, because this one is not important for me. I'm working on this plane. Another line here and here, and I'm gonna to use 3 points arc to build this circle, this arc. Now it's time to say this is sketch, this circle is tangent to this line, here is tangent. Okay, dimension, this one is 20, sorry, this one is 20. Why? It should be 20. Okay, and let's say dimension 21. Yeah, here to here is 21. Okay, since we made a tangent here and this center is on the mid of this line, we don't need to add any dimension for this arc, because automatically it will be possible to, by the application, to select as 21. So isometric, we have this sketch. Okay, even let's say, let's continue on this sketch and make a circle here, and radius of the, the diameter of this circle is 20. Now we build this sketch on this plane, plane 1. Now feature extrude. When I'm extruding a sketch, all the times I have extrusion in one side, okay? But the ones which I'm looking here is to extrude the part in 2 sides. In direction 1 as, look, as 7.5, and we can activate the direction 2 as well as 7.5. Okay, so as you can see here, my sketch is placed at the mid of the direction 1 and direction 2. Okay, so totally the thickness of this part will be 15. So confirm it. We build this part. Now I'm gonna to add some fillets to this part. Fillet 5, this one, this one, this edge, and this edge should be filleted as 5. Okay, we don't need to work again on this plane, that's why I can hide it. Okay, select this plane, normal to circle, build 2 circles. Definitely these 2 should be equal, not concentric, sorry, Control Z. These 2 is equal. Okay, now what is the diameter? 12. This point and this point is horizontal. Let's say here to here is given as 10.5. Am I? No, 21. Sorry, 21. Okay, and here to this center it's given us 24. This one to here is 24. So as you can see, now the color of the lines and circles is black. We can continue. Isometric, feature, cut extrude, and through all. Now, isometric. We build this part here, okay? Now I'm gonna to use this part to create a technical drawing of the part. As always we did up to today, okay, we only create the parts, but we are gonna to use this part in order to make a drawing. Now, firstly, I should save the part, save. Okay, let's say this PC, this is my part 3 in my case. You may put a name for your part, okay? Now, be careful if you do not save your part, it is not possible to continue. That's why you should definitely save your part, okay? I saved the part. Now I can go to file, make drawing from part, okay? Now, as you remember, when I'm gonna to begin a new part in SolidWorks, I should select part, drawing, or assemble. So here we made the part. Now we are gonna to shift the part into a drawing, make a drawing from part. Okay. Drawings is 2D most of the times. Drawings is printable because you will print your drawing. It should have all the dimensions of the parts, okay? Because this drawing is gonna to be used in your workshops in order to build a part, okay? We may have many choices of the size of the papers. Standard sizes is A0, A1, A2, A3, and A4. The biggest one is A0, be careful, okay? And the ones which we are all the times working on it is A4, okay? When I'm selecting A4 size of the paper, as you can see, the size of the paper will be increased, okay? Now, if you select the paper, we have a table of contents for the paper. We can adjust this paper table of the contents, but we are not gonna to talk about this. Later on drawing part, I will give many details for this technical, this table of the contents. But select the A4 size paper and then select custom sheet size. If you do so, this one, since A4 is selected, the width or height of the paper is given as 210 millimeters, 297 millimeters. This is a standard size for A4 size paper, and as you can see in preview of the paper, it is full of nothing. It is empty, it is blank, okay? Now we are gonna to do so, but be careful. If you go back to here, for example, if you wanted to see the A0 size paper and custom, this is the size of the A0 size paper, but it's quite big for us. That's why we are gonna to work on A4 size paper, and we will build. This is my paper, okay, A4 size paper, and automatically we have many views of the part in my cases, okay? Most of the times in technical drawings, having 3 views of the part is quite enough for demonstrating all the details of the parts, okay? Most of the times we are using front view. It means that the part is on front of my eyes, okay? We are using right or left, right or left. Right means having a look to the part from the right, okay? Left means having a look to the part from the left, okay? And third view, most of the times which we are using in technical drawing, is top, okay? So totally we should put front, right, top, or front, left, and top. When we have to select right or left, it's depend on the part. If we have too much detail on the right, definitely much better to put right view, okay? If your details of the part is on your left, okay, you can put on the left. But if your part have many details, okay, here as you can see we can put many views. We can have 6 views: front view, right, left, top, bottom and back. If your part is very complex, in our cases most of the time we are not going to deal with very complex parts. That's why if your part is very complex, definitely you can put 6 views of the parts. But in most of the cases our part is symmetric. Okay, that's why right and left views or top and bottom views will be look like each other. That's why we don't need to put it. Now most of the time we will start in drawing, we are gonna to start with front. Look, I am picking this part, front view here, and placing on the paper. Okay, now if I put this one, automatically I can see right view, I can see top view, left view of the parts and bottom view of the parts. Now I'm gonna to put top, click, and right. By click I can create front view, right view. Be careful, right is on the right of the front, top is on top of the front. Okay, now back to here. Look here, I'm clicking on this and back to here. I try to create front, right and top. Now much better to put isometric view of the part here on the paper. Now look here at the right here. Look, for example, when I'm selecting here, I can have many I have a drawing views details here. Okay, in display style, much better to show, to activate the hidden lines. Hidden lines is the lines which is not possible to see when you are looking directly to the parts. But for example here, if I activate my hidden lines, you can see I have some dashed line. It means that some things is on back of this view which is not visible for me. For example, these two, if you have a look to the right, these two belongs to this hole. Okay, and this two belongs to this hole and this one. Okay, now as you can see we have many hidden lines here. Now let me increase the scale of the parts here. Scale, use the 1 by 1. Okay, 1 by 1 is the same size. Look here, I have to separate it a bit. This one, let's scale it as 1 by 1. Use custom made scale and 1 by 1. Okay, so look here, just few seconds. I have a part here. Okay, this is my part. Here is the front view of my part. This one is right view of my part. Okay, and this one is top view of the part. Okay, now commonly we should put dimensions for our parts. Look here, if you use smart dimension here and try to put all the details here, you don't need to put any numbers. Okay, but if this one is 98, okay, automatically it will be able to find this dimension. This one to here is 22, for example. As much as possible, try to select 2 views here, front or right, front or top, or right and top, and put all the dimension in these 2 views, for example, not on the selected views, not on all the 3 views. For example, this one, since it is circular, much better to select this. This one is 21. Here is let's say 20. This is for let's say 22. Here to here is 12. Here to here is 12 again. Okay, now here this height, oops, this height is given as 42, and look, this one is 5, 5, 5, and 5. Much better to put all the dimensions. And this one is 70. Here is dimension. Here is 40. Okay. And this one is 5. It seems that we put all the dimensions here. Okay. Now, as you can see, I used only these two views in order to put all the dimensions. Now, if you print this paper, okay, and give this paper to workshop, definitely by this information they can build this part. Now, the question may come to, let's say, save. Okay, when you are saving, this part will be saved as a drawing. Okay, now the question which might come to your mind is, okay, I'm gonna to I made this drawing, but what will be happened if my, for example, workshops do not have Solidworks application for opening it? Okay, definitely this is an issue. Or if you wanted to print this paper, okay, and you don't have any printer in your home, how it is possible to print it? Definitely we can go to file, and most of the times, since we are not gonna to share the technical drawing of the parts with our competitors, that's why we are getting the PDF format of the parts instead of, or JPG. This is a PDF format, okay, and it will be, we will put a name for this PDF, okay, and definitely you will be able to find, just for seconds.